All right, guys. So taking a look at this lesson, okay, what we're going to see in this particular lesson is a little bit more complicated in terms of actually calculating the derivative. And it's because we are going to see chain rule appear within product and quotient rule. Okay, so we're going to have it's almost like derivative laws inside of derivative laws, right? And I suppose, like, just looking at the first question, you might think, oh, this is going to be okay to derive. And after you do a couple of them, it's going to be. But you have to think about the fact, okay, well, if I bring this 3 down, like I have a function inside of a function here, and I have chain rule. But in addition to having the chain rule on the first one, you got to realize too, you have a function like, let's say, I'll erase this. Let's say g of x and h of x, right? So you have two functions multiplied together, so you got to apply the product rule as well. And I suppose if we were to think about, if I was trying to find the derivative of f of x, f prime of x in terms of quotient rule is going to equal g prime of x multiplied by h of x plus, then I have to add the derivative of, the original g of x function multiplied by h prime of x. Okay, and where you're seeing this chain rule with product rule and quotient rule is inside each of these derivatives. You have to apply chain rule. Okay, and so this is going to be like our parent, what we're going to kind of follow here for this particular question. Same thing down at the bottom, right? You're going to have chain rule inside of product and quotient rule. Okay, and that's what makes these questions more complicated. Okay, and they get more complicated because we saw with chain rule, we saw two terms come out for the derivative. So you can imagine with a chain rule inside of product rule, you're going to have more terms start appearing, okay, and just more to deal with. So let's take a look. Let's actually calculate the derivative then. Right, I think the derivative piece is not necessarily, as long as you're organized and you're following the what rule you've chosen. It's not necessarily the derivative that's the hard part. It's the cleanup after, I think, as you'll see. Okay, so what we're going to see here, let's try and calculate f prime of x. Well, f prime of x tells us, okay, well, I got to calculate the derivative of g of x. Okay, so let's do that. You'll notice I have a composite function, a function inside of a function. All right, and so I'm going to bring the 3 down, and I'm going to have 3x squared minus 1, and then I have to put the squared. But then I have to multiply that against the derivative of the inside, right, in order to actually calculate g prime of x, which is the very first thing I need to do, right? So I need to multiply by 6x. And then it tells me, product rule tells me, okay, I still got to multiply by h of x. So I got to rewrite this h of x function here. 2 minus 5x squared. Okay, that takes care of the first half of this. Now I have to do the second half. Well, second half tells me I got to take the original g of x function, so write that down. 3x squared minus 1 cubed. Oops. Right, and now I have to calculate the derivative of h of x. Okay, well, same thing. We're going to apply our chain rule. So we're going to get multiply against 2 times 2 minus 5x to the power of 1, and then multiply by the original h of x function, so 2 minus 5x squared. Now, sometimes cleanup can be difficult, and sometimes cleanup can be a little bit easier. And I think, like, one thing you should resist the urge to do is just start expanding all of this stuff and then collecting like terms. I suppose you could do that, but that's a lot of work. What I see off the top is you can combine some things, okay? Just in looking, I just gonna, like, I'm gonna combine this with this just to try and minimize the number of terms that I'm seeing, okay? So I'm gonna do that first. Oh, I did something wrong here. times the derivative of the inside is negative 5. Okay, sorry guys. This is this is h prime of x. Sorry, right? I took the power, I brought it down, it became a 2, I multiplied by the inside, and then I derived the inside and multiplied, sorry. Okay, just made a little mistake there. Okay, so I'm gonna try and clean things up, right? So I can combine this with this as well. So why don't we do that and then see what we're left with, okay? So f prime of x is gonna equal, we're gonna have 18x multiplied by 3x squared minus 1 squared times 2 minus 5x squared. And then I'm going to have a minus 10 from those two numbers there, right? Minus 10. And then what's left? Well, we have 3x squared minus 1 cubed and times 2 minus 5x. Okay. Now, something else can go on here. Okay, if you're looking at this, just look at this as a big picture thing, right? Two big terms. Here's term 1 here, and here's term 2 over here, right? And they're separated with a minus sign. You can look at those two things and think, okay, well, I see a couple things in common, right? Like something I could factor out. Well, I could take out, let's look at the number. I could take a factor of 2 out from the numbers. Okay, so let's do that, right? So f prime of x is equal to 2. I'm going to take a factor of 2 out from the numbers. And then, just by looking at this, it looks like I can remove 2 3x squared minus 1s, right? So I can say, okay, well, 2 times 3x squared minus 1 squared. And then it looks like, oh, I can take a 2 minus 5x out as well. Now you tell me what's left. You know, this is what you would call from grade 10 your greatest common factor, right? So now you tell me what's left on the inside of this square bracket. Well, if I divided 18 by 2, that's going to leave me with a 9x. I removed both of the squares, so that's going to be taken away. And I removed one of the 2 minus 5x's, right? So I'm going to have 9x times 2 minus 5x. And then I'm going to subtract off 5, right? Because the 2, when I remove the 2 from the 10, I get 5. And then it looks like I've removed 2 of the 3x minus 1s, right? 3x squared minus 1s, okay? And then I removed 1. I only had 1, so that takes care of that. So here's your final answer. Okay? You could further expand that, keep going. Let's do it. I guess maybe not the final answer. Let's keep going. Okay, we can, f prime of x is going to equal 2 times 3x squared minus 1 squared. Okay, and I'm just going to expand all this out and try to clean some stuff up, right? And see if I get anything to cancel, right? Well, okay, so we're going to get 18x minus 45x squared. And then I'm going to have minus 15x squared plus 5. And clean up the inside. Right, I'm going to get f prime of x is going to equal 2 multiplied against the negative 60x squared plus 18x plus 5. Okay, and I suppose sometimes the convention could be to not, I don't know, bring the negative out front, so you could factor a negative out, and there you go, and change the. But if you did that, you'd have to change the signs on these two as well. Okay, So that's a more complicated example, right? And it's more complicated from the standpoint, I mean, as long as you can figure this out from the beginning, right? As long as you follow it step by step and do what it tells you to do, you know what I mean? Like it's not too crazy. It's some of the cleanup after that can be a little bit challenging. Staying organized, right? Which is not one of my strong points. Trying to get ahead of myself, you'll see, like, even if you just gotta be careful if you make a mistake, right? Remember, you know, gotta follow this entire process all the way through, right? Make sure you follow chain rule to a T, and chain rule is a part of the bigger picture of product rule. Okay, so we're gonna do another one down here. This one's a little bit shorter, but this time we have a quotient. Okay, we're gonna apply quotient rule. Well, remember what quotient rule told us, right? So if I was to derive, again, I have a g of x function here, and I have an h of x function there. Remember what this told us. It says f prime of x is the derivative times h of x minus the original g of x function times h prime of x, all divided by g of x. Oh, the denominator, sorry. Get used to writing it out. H of x squared. Okay, so here's the rule again. You're just going to follow it. And inside of these specific derivatives, you're going to have chain rule, right? Because remember, the 4, if I was to rewrite f of x here, we could rewrite f of x as, you could rewrite f of x as being, do I want to do this? Remember, the 4 is going to distribute into both functions there, right, from the outside. Okay, the reason why I'm a little hesitant to do that is, remember, if I was to derive this right off the top, I can make my life easy by going like this and bringing it down. It's almost like a big chain rule. Okay, so I can, this one almost seems like a chain rule with quotient rule inside of the chain rule, right? That's what's interesting about the difference between these two questions. Up atop here, I had chain rule inside of product rule. It looks like I have quotient rule inside of chain rule this time. Okay, so it's a little bit different. Interesting, right? F prime of x, I could go, okay, 4 times 3x minus 1 over 5 minus 2x to the power of 3. Now, that takes care of the chain rule piece, like the first part of chain rule. Now, the second part of chain rule tells me to derive the inside, right? But the inside is a quotient. So I'm going to have to follow my quotient rule in order to derive the inside, right? So let's do that. It tells me, here, let me just erase this so you can see. It tells me I got to derive g prime of x and multiply that against the original h of x function. So let's do that. So I'm going to derive the top g of x. That's going to be 3, right? And that has to be multiplied against the original h of x function, 5 minus 2x. And then I have to subtract the original g of x function, and then multiply that against h prime of x. Well, the derivative of h of x is going to be negative 2. All that needs to be divided by 5 minus 2x squared, the original denominator. Okay, so again, a little bit challenging, this question, actually. It caught me off guard a little bit, right? We have chain rule, right? We can apply our chain rule. And then you could use your quotient rule after. Now, the tricky part here is, like, if you had have done what I did initially, I think that would still work. If you rewrote the function as 3x minus 1 to the 4 over 5 minus 2x to the 4, I think you could still, derive like you have quotient rule, right? So you could say, okay, well, I'm going to derive g of x. Well, what is the derivative of g of x? Well, it would be 4 times 3x minus 1 cubed times 3, right? Times the original denominator. But I think that's going to be more complicated, right? And don't forget, you got to subtract that off and keep running with it, right? So I think this was the smarter decision in the above way, okay? To actually use quotient rule inside of chain rule instead of vice versa, okay? Because I think this bottom way here, I think that's going to get much messier than if just the top. Okay, we're going to get it an answer quicker. Okay, so both would have worked, but again, it comes down to which one's going to be the most efficient way, right? Because the most efficient way is also going to prohibit you or have less likelihood of error. Okay, so let's just keep running with this. Okay, so I'm going to get, it looks like I could combine. What's next? F prime of x. I'm just going to try and clean this up here, right? We could do some expansion, I think would be the next step here. So we'll rewrite this. 3x minus 1 over 5 minus 2x, right? And we're going to multiply, that's to the power of 3, sorry. And then we're going to multiply that against, let's clean up the numerator, right? So I'm going to get 15 minus 6x. And then I'm going to add, I'm going to add because of the minus and the minus, 6x. Here, let's be careful. Minus, let's just distribute the 2 in first. Negative 6x plus 2. Okay, let's be careful. That was good. Okay, now we could distribute that in and do the cleanup. Okay, so we could say f prime of x. And I'm going to cheat here a little bit, just to save us some time. Okay, we're going to make this a plus 6x minus 2, right? And so we're going to end up with something a lot smaller. We're going to have negative 6x plus 6x. That creates a 0 pair. And so we're going to get 15 minus 2, which will be 13, right? So we have 13 over 5 minus 2x squared. And I could combine, I'm just going to do one more thing here. I'm going to rewrite this. I'm going to get 4, right, times, this is going to be 3x minus 1 cubed over 5 minus 2x cubed, right? All I did was put the cube in. And then that's multiplied against 13 over 5 minus 2x squared. Okay, and your final answer, we can combine the 4 with the 13. That's going to make 52 times 3x minus 1 cubed over, now you have bases that are the same, you can add the exponents. It's going to be 5 minus 2x to the power of 5. This is going to be your final f prime of x for this question, okay? So a little bit more complicated, obviously, right? When you have, we're combining derivative rules now, right? So a little bit more complicated, but applicable, right? Because we need to be able to derive anything that's put in front of us, especially when it comes time to looking at the real world around us, right? And how things change in our real world. Like, you could have really messy functions that require you to apply multiple derivative laws at the same time, okay? And so I just wanted to take some time and get you guys do a couple examples and allow you guys some time to work on um, more complicated examples, because that's just going to reinforce your understanding of product rule, of chain rule, of quotient rule. Okay, and working on harder problems like this is just going to reinforce things. So I give you the time today to work on some harder questions. This is pretty much the end of the unit, with the exception of this afternoon's lesson, where we're looking at implicit differentiation. Okay, um, and then your test on Monday will just be a differentiation test. Can you derive the following? Okay, and there's a practice formative up there for you today as well. Okay, so you guys let me know if you have any questions, and I'll be around all day today.